What if I told you that a telescope, floating a million miles from Earth, just caught a glimpse of what might be alien city lights on a planet 4 light-years? Wait, no science fiction, no Hollywood effects, just real data from the James Webb Space Telescope that's shaking the foundations of what we thought was possible. Today we're diving into the mind-blowing discovery that could be humanity's first clue that we're not alone in the universe. The James Webb Space Telescope has revealed something truly astonishing. Beams of light that seem to emanate from a bustling metropolis shining from a location 4 light-years away. This extraordinary discovery has reignited our curiosity about the possible existence of extraterrestrial life. The telescope turned its attention to Proxima Centauri b, the closest exoplanet to our solar system, and detected mysterious, dazzling flashes of light. Could these signals be evidence of an advanced alien civilization? Stay tuned as we unravel the mystery. For centuries, both scientists and the public have been captivated by the idea of life beyond our planet. Any hint of extraterrestrial life has sparked widespread excitement. But a momentous breakthrough occurred when the James Webb Space Telescope uncovered clear indications that life might exist elsewhere in the cosmos. While peering into the vast expanse of space, this remarkable telescope made an incredible discovery. It found lights on an exoplanet far away, reminiscent of the glow from alien cities, raising the tantalizing possibility that a thriving metropolis could exist on this distant world. This concept has ignited a firestorm of intrigue and anticipation within the scientific community, as it could be the monumental revelation they've long awaited to suggest the existence of intelligent beings managing civilizations in ways we are only just beginning to imagine. From an awe-inspiring distance of 4 light-years, NASA engineers are stunned, wondering how long these city-like lights have been visible, quietly waiting for our technology to evolve to the point where we could detect them. David Kipping, astronomer at Columbia University, has described the planet where these lights were observed as intricately unique, unlike the majority of rocky planets that absorb sunlight and emit energy as infrared radiation. This exoplanet behaves in an entirely different manner due to its unusual interaction with its host star, Proxima Centauri. This remarkable discovery by the James Webb Space Telescope highlights the telescope's pivotal role in unlocking the mysteries of the universe. The ability to capture infrared wavelengths was critical in identifying the peculiar behavior of Proxima Centauri b, which is vital to understanding the planet's atmospheric conditions. The significance of this finding has prompted scientists to plan further studies using the telescope to explore the atmosphere of this planet in even greater detail, with the hope of uncovering whether it could sustain life. The Webb telescope, with its exceptional sensitivity to infrared light, allows us to observe Proxima Centauri b's behavior even during the planet's night. While many telescopes struggle to detect faint light in the vast blackness of space, the Webb telescope excels at catching even the faintest flickers. This makes it the perfect tool to confirm if the mysterious city lights on the dark side of Proxima Centauri b are in fact real. The telescope can detect artificial light in space provided it falls within a very specific frequency range, much narrower than the light emitted by regular stars. Proxima Centauri b has a dynamic relationship with its star which profoundly impacts its environment. Many planets, it absorbs intense energy from Proxima Centauri as it orbits its star. The planet cycles through periods of day and night, much like Earth. During the day, the planet experiences scorching heat, while at night, it cools down significantly. Temperature Fluctuations on Proxima Centauri b are vast, mainly due to its unique composition. For instance, if the planet has no atmosphere, the temperature difference between day and night could be extreme, burning hot on one side and freezing cold on the other. Dramatic thermal variation is of great interest to astronomers, offering valuable insights into the makeup of Proxima Centauri b's atmosphere, thanks to the James Webb Space Telescope's ability to capture infrared images. Scientists can effectively study the planet's thermal emissions and gain a deeper understanding of its atmospheric properties. The role of Webb in these future discoveries is crucial. Interestingly, the orbit of the James Webb Space Telescope around Earth coincides with Proxima Centauri b's orbital period, allowing scientists to observe the planet's daylight cycles every 11.2 Earth days. Proxima Centauri b harbors an atmosphere. The next logical step will be to analyze its chemical makeup to determine if it could support life. Detecting key elements, such as oxygen, water vapor, and methane, would indicate that the planet has the potential to harbor life. This would involve studying the light filtering through the planet's atmosphere, a complex process in itself. While the James Webb Space Telescope excels at analyzing planetary atmospheres, its primary purpose lies elsewhere. Particularly adept at measuring concentrations of water vapor, carbon dioxide, and methane, but is not as efficient at detecting free oxygen, crucial sign of biological activity. Nonetheless, the telescope can still search for other important indicators, like ozone, which signals a healthy, life-supporting atmosphere. As researchers continue to analyze the data collected by the Webb Space Telescope, the search for distant worlds progresses. The search is bringing us closer and closer to answering one of humanity's most profound questions. Are we truly alone in the universe? It's important to recognize that the James Webb Space Telescope is only able to observe a limited number of exoplanets that are in relatively close proximity to Earth. To delve deeper into the study of planetary atmospheres, astronomers will rely on ground-based observatories such as the Extremely Large Telescope (ELT), which is set to begin operations in 2028. The is designed to provide a more in-depth examination of the atmospheric structures of far-flung exoplanets, offering clearer and more precise data on their potential to support life. Final thoughts. Researchers have ambitious plans for future space telescopes. They aim to develop technologies that minimize starlight interference, enabling better observation of the planets that orbit around them. Much like shielding your eyes from the sun to see more clearly, these future telescopes will be able to focus on the faint light reflected by exoplanets, making it easier to analyze their atmospheres and assess their potential to support life. However, the task is no small feat. Stars are incredibly bright, often overwhelming their neighboring planets with their luminosity, which makes it challenging to detect the faint light that planets reflect, essential for studying their characteristics. To tackle this problem, scientists are exploring a range of innovative methods. One promising technique involves the use of coronagraphs, special devices placed inside telescopes to block starlight, while allowing the planet's light to pass through. By carefully manipulating the light waves, coronagraphs can reduce the brightness of the star, making it easier to detect the dim light of exoplanets. Another exciting approach is the star shade, a massive flower-shaped spacecraft designed to fly information. With a telescope positioned tens of thousands of kilometers away, the star shade will block starlight before it even enters the telescope, ensuring that only the light from the exoplanet reaches the instruments. This technique could prove especially effective for observing planets in the habitable zone of their stars, regions where liquid, water and possibly life could exist. These advanced technologies, however, require exceptional precision. For instance, aligning a star shade must be done to within fractions of a millimeter over vast distances. Furthermore, these innovations must overcome the challenges posed by space missions such as the need for miniaturization, energy, efficiency, and the ability to endure the harsh conditions of space. Despite these hurdles, the potential rewards are immense. Successfully observing and analyzing the atmospheres of exoplanets could lead to the discovery of signatures, chemical indicators of life, such as oxygen, methane, or water vapor, in specific ratios. These molecules could suggest the presence of biological processes, providing compelling evidence that life exists beyond Earth. Researchers are also exploring ways to directly capture images of distant worlds in far greater detail. Future telescopes could be equipped with advanced adaptive optics which adjust for distortions caused by Earth's atmosphere or the movements of the telescope itself, producing sharper images. When combined with starlight blocking technologies, these improvements could enable scientists not only to detect exoplanets but also to map their surfaces and examine their climates. The development of next-generation space telescopes represents a monumental leap forward in our quest to answer one of humanity's most profound questions. Are we alone in the universe? By enhancing our ability to observe these distant worlds, we are drawing closer to uncovering whether life exists beyond Earth, potentially revolutionizing our understanding of our place in the cosmos. The future of space exploration and the search for life beyond Earth is advancing at an unparalleled pace. As scientists and astronomers probe deeper into the mysteries of distant exoplanets, the James Webb Space Telescope is ushering in a new era of cosmic discovery. The data it gathers is helping astronomers make groundbreaking revelations about the structure, composition, and habitability of far-off worlds. With every new piece of information, we move closer to answering the ultimate question: is there life beyond our planet? Proxima Centauri B's discovery is just the beginning of what could become a monumental turning point in how we study extraterrestrial life. As the closest star to our own solar system, Proximus Centauri has been the subject of intense research for years. Yet until now, the idea of discovering concrete evidence of life, like artificial light or signs of civilization, seemed like a distant dream. The fact that such light has been detected by the Webb telescope only heightens the hope that one day we may come into contact with other intelligent life forms across the universe. This kind of discovery sparks both scientific curiosity and public imagination, inspiring new generations to look beyond the boundaries of Earth. As the James Webb Space Telescope continues its observations, it's not just searching for artificial lights, but also focusing on planets' atmospheres, their chemical makeup, and the conditions that could support life. The hunt for signatures like methane or carbon dioxide in the right concentrations is essential for understanding whether these planets could sustain life. The Webb telescope's unique ability to examine these atmospheric components sheds light on the potential of distant worlds to support life similar to Earth. Perhaps the most captivating aspect of this endeavor is that we are observing the past. The light from these planets takes years to reach us, meaning what we see today actually happened years ago. Each discovery is a glimpse into history, a cosmic time machine, showing us the universe as it once was. As the data from the James Webb Space telescope continues to pour in humanity, stands on the brink of a new era, an era where questions once deemed impossible, like the existence of alien civilizations, may finally be answered.